Okay, with our super evidence debrief, we want to think about big ideas from our one, putting the maps together, and two, observing that map change over time. So you're logged into your green study guide. We already did Shell of the Earth earlier, so if you need info on that, check out the study guide resources, debrief 1. But here you can put your title in for super evidence. This is going to be our debrief number 2. So once you have that title in, we're going to pop in just 3 bullet points, 3 key ideas or observations or things you noticed from our super evidence and our short little conversation here. I know normally I say, hey, let's write this down, or hey, draw this diagram, but today is a little bit different. You're just going to be looking for 3 information pieces as we detail a couple things out, and maybe I'll repeat something a few more times than others. That might give you a little clue. Hey, that should be something that I want to get in. So our whole focus for this introductory week has really been puzzles, right? So first day we did like actual puzzles. Then we shifted to the egg. We put the puzzle, we like made the puzzle, right? And then we took it apart, tried to put it back together, and then you did the actual map puzzle. And even though everyone did a little bit different of a puzzle, I think you maybe noticed that this was the easier of the puzzles to put together. So the question is, why? What was so much easier about this puzzle compared to this one? Well, I think a lot of us agree here with the egg puzzle, I really had nothing to align, right? When we're doing our puzzles on Monday, what we noticed is we were trying to match things based on either the shape of the puzzle piece or like the coloring of the puzzle piece or the picture, the pattern, right? So these are our 2 clues to know, hey, is our puzzle being put together correctly or not? Well, with the eggshell, all we really had was the shape. And those shapes didn't really last very long. Some of them, even if we were very careful drawing them out, broke quite a bit, right, in our extraction of those. So even though we had an original shape to put together, it was still difficult. Plus our coloring, as you can see, is all the same. White, 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 right? So no way to match anything over there. Well, on our map puzzle, we still had shape, right? We could put together coastlines or edges that essentially mapped, but also we were putting together coloring or pattern. So we noticed these 3 areas were all that black color pattern. So we thought, hey, there might be something to match up there. Brown stars, in this one, green lines, blue hexagons, and so on. So as we think about what those mean, all those colors and patterns, they were examples of rocks and fossils found in that location. So here, with this white area, black area, this was our fossil fuel deposit. Here we had halite deposits. Here we had an ancient fern that was found in all of these locations. So the idea is putting it together with a puzzle, matching up colors and shapes, right? So that's kind of our big number 1, is we're able to put these geologic maps back together from 150, 200 million years ago by matching, just like we would with a puzzle, the shape, the rocks, and the fossil patterns. So again, a really big idea we're thinking about here is being able to recreate what the Earth used to look like using rock, fossil, and shape of the continents. So then the next question is why? Why is it that when we see a fossil in 2 different areas, we go, oh, what a great idea to re-hook it back up? You know, obviously puzzles is on our mind, so that's what we were kind of ready to do. But what is the reason that I can say, well, if the fossil is found here, then the fossil found here had to be the same spot? When we think about what a fossil is, it's showing us what organism used to live in that location. So here, an ancient plant, this Mesosaurus, the swimming guy you looked at, the lithosaur, kind of the dog-like burrowing creature. This one we didn't see in our investigation, but another common one here. So why is it good for me to reconnect those? Well, when we think about what the fossil is, it's that remains of a living thing. So what the fossil and the rock really tell me about is what that environment used to be like. It tells me it used to be a lot of fresh water, or a warm rainforest, or a desert-like climate where the animal can burrow into with lots of vegetation. So the environment is our clue, because the earth is very diverse. While we have areas with similar climates, we don't have two identical climates in very different locations. And when we look at these patterns and we think about these patterns, what they look like today, well, we're looking at places that are across oceans, right? Look at this one, Antarctica and Australia. How would that plant have gotten all the way across those landforms to exist in the exact same way in both spots? Plus, when we think about what Antarctica is today, could it have housed this beautiful rainforest type fern? No, it had to have changed. And so we're able to reconnect these to this pattern because of the environmental clues that both the rocks and the fossils give us. They tell me, hey, seeing that one thing in two different locations tell me that those two locations had to be one location at some point in time. And as you can see in this animation rolling over here, this is the general trend of what we've seen with continents or land pieces over time. When we recreate these maps using our clues of rocks, fossils, and coastlines, we see that over time, the last 250 million years, that those things have separated, right? We've seen them drift apart. Right? And if we were focused on a couple continents, we could say South America and Africa especially. We could say Antarctica and Australia specifically, right? And depending on what continent you look at, there's maybe more movement than others. I know in class we talked about like Eurasia pretty much stays put. North America doesn't move a whole lot, but like India here, if you watch it, it's going to move pretty fast and pretty far compared to some of the other continents' motions. So in general, we're seeing them drift apart, but again, specifically, we can track different movements of different continents. So last big idea is this is what we've seen the last 200 or so million years, what's going to happen in the future. So if we fast forward 200 million years, we're going to see those continents continue to drift apart and essentially combine in a totally different way than they were before, right? As they continue to move in separate directions, they will reconvene and make kind of a new and different Pangea, that time when everything was combined into one land mass. So these are all the big ideas that we talked through. Why were we able to put that puzzle together? What clues did we use? Could be thinking about that. Why are fossils and rocks good evidences reminding me to be able to reconnect? What's our general pattern of how those land masses have moved in the last 200 million years? And how will they keep moving as we think forward? So your goal was to have 3 bullet points throughout that discussion. If you need to rewind or go back or just pause and look at these questions lists, you can do that and get your debrief wrapped up.